First of all, a very warm welcome to all the participants who have joined us for this first interaction session in celebration in the this whole plan of celebration National Science Week. And in inaugural function, most of you were in the meet when we conducted inaugural function on 22nd February. At that time, our directors attending, everybody talked about why we are celebrating this and what is the importance of science and technology in this phase of when we see how it connects to our regular life. So today we are holding in this series of events. We have three interaction sessions scheduled on the 23rd, 25th, and 27th at the same time. And it is the first interaction session. And for all the interaction sessions, we have been inviting experts from different fields who are working in the very core of research and industry and all the things. They can tell a lot of things which the people, most of the participants are undergraduate science and technology students. So for them, they may have a lot of questions about what they can do in science, what are its application to our daily life, and science career in science, and what the people do who are at the top of this whole work. So since this National Science Week is celebrated to showcase our achievements, our progress, and our legendary history from the people who have started from very basic, like when country, our country got independence in 1947, and a lot of issues were there at that time. And the people who were best at the core of it, they started the process of nation building. So when we are celebrating science, so it is not only about our country, but how in such a small time, what kind of achievements we are making in there. You see, very recently, this corona pandemic, and in 8 months, very short time for such development, and our own scientists have developed two vaccines, so we can take proud on that. And when we are celebrating science, when we are talking about the science and technology, such kind of celebration is basically to showcase that our real heroes are not. Many times we don't see them on screens, we don't see them performing super action kind of thing, but the real heroes, they work in silence, they work in labs, they work day and night, and then we get the achievements, then we get things done in our life. And the curiosity, the question when we ask about our the things we are happening around us, when we try to look its region, when we try to understand why it is happening, then this question of why, how is being addressed best at the science. Science is basically a systematic study of life around us, the problems which we are facing. We look forward solutions of that, and in our country itself, we are achieving excellence in very different fields, like you see in space technology. Indian Space Organization is achieving milestones like Chandrayaan, Mangal mission, and a lot more things are coming in. So the people who work behind it are who are the people and how they work, and how they get into that. So all the young generation, the young people, जो लोग हमारे साथ जुड़े हैं अभी यहाँ पे, ये सब लोग कभी न कभी, क्योंकि साइंस और टेक्नोलॉजी में वो अपना कैरियर देख रहे हैं, तो दे मस्ट हैव क्वेश्चन अबाउट कि कैसे ये सब होता है, कैसे हम रिसर्च में पहुंचते हैं, कैसे ये सब कुछ अचीव होता है. दिस प्रोसेस, a lot of curiosity comes in mind when we look at things. So today we are hosting this first interaction session, and we have invited very two experts for this interaction session, and I will be introducing both of them so that you can get a glimpse how what they are doing and what how they get into that. So while looking for experts, I try to keep this in mind that we go for the people who are working in the fields and they are young people, so that you can interact them, you can ask frequently. जो भी तुमको पूछने का मन करता है, you can ask your questions. कैसे साइंस कैरियर के बारे में या जिस फील्ड में वो लोग काम करते हैं उनके बारे में. तो हमने आज दो लोगों को बुलाया है, and they work in their field. They have very busy schedules, but the good thing is that they are very enthusiastic about the young generation. जो नए लोग हैं, जो नए लोग उसमें आना चाह रहे हैं, जो नए तरीके से सीखना चाह रहे हैं, they are open there to share their experiences, to tell the path how to move further, how to achieve things. And their areas of expertise, I have shared this in group also. So first of all, let me introduce my experts for this today's session. So we have Dr. Navpreet Kaur with us. She's currently joined us from Stockholm, Sweden, and she is currently working as postdoctoral fellow at KTH Royal Institute of Technology, Department of Physics in Sweden. And she's, by profession, she's an astronomer. She's working in astronomy and astrophysics. And she's one of us. Like अभी जैसे तुम लोग पढ़ रहे हो, ऐसे ही कभी हम लोग तुम लोग से कुछ पहले ऐसे ही पढ़ रहे थे. And now she's exploring that field, and she's contributing a lot of things in the research. She's very active in science outreach. So it is a really good opportunity for all the participants to get an idea what it means. So let me introduce some more about her. She completed his master's degree in physics from Department of Physics, Punjab University, Chandigarh in 2012. And then she joined a very elite institute of India, Physical Research Laboratory in Ahmedabad. So this is the institute where ISRO started. Dr. Vikram Sarabhai, who is known as father of Indian space program, he started this lab, and now you see a lot of things, a lot of achievements in this. So she worked there for her doctoral thesis. She completed a PhD in astronomy and astrophysics from Physical Research Laboratory in 2018. And later, she worked as a postdoctoral fellow in Physical Research Laboratory, and currently she is a postdoctoral fellow at KTH Royal Institute of Technology at Stockholm, Sweden. Apart from this work, she has traveled at many places and presented her work at various national and international forums. And apart from this research work, she is very active in science outreach. So when I asked her to join us to share her experience, she very kindly agreed, and found out time for us from her busy schedule. So she recently in outreach activities, she is part of United Science Forum, core member of United Science Forum. It is an organization who is active for science outreach to the students, to the young student in rural part of India, and they organize a lot of events. So recently there was a science Mela in Ajmalpur in 2019, and she actively participated in and a lot of young students. They asked their curious question to get into that. So the people who are from underprivileged background, remote villages, and technology has provided us an opportunity to interact uh, such experts who can share, and they are really interested to uh, motivate you for to achieve a career, to move further, to contribute your things. So also in physical research laboratory, when she was there as a PhD student, she participated in a National Science Celebration. There is also a big program on National Science Day, and she used to work there to motivate younger students. So it is a great opportunity for us that she is here live with us to take your questions, to share her experience. And so thank you, Navpreet, for being here. Can you, Navpreet, are you? Yeah. Okay, so here is one of from expert panel. So thank you, Navpreet, for taking time from your schedule and being with us. Thank you so much.
Thank you, Lalit, for having me here and for the nice introduction. Yeah.
Thank you. And let me, in the continuation, let me introduce our second expert, who is live with us from Ahmedabad, India. He is currently Dr. Manish Sanghani. He's with us from Ahmedabad, India, and is currently working as postdoctoral fellow at Physical Research Laboratory in Planetary Sciences Division. And it is really, I'm really excited to have you here, Manish. And let me introduce a little bit about what kind of work he does. And so Dr. Manish Sanghani has obtained his bachelor degree from Kotak Science College, Saurashtra University, and a master's degree from Sardar Patel University in Gujarat. And apart from this sense, how you can see that he has worked as a science educator in about 2 years at Vikram Ambalal Sarabhai Community Science Center. So it is a center in India which is completely dedicated for that how to make young people inspired in science, and teach young students by very easy experiment, very lively interaction. So he has worked there as an educator. His passion for science education is unparalleled. And he was also part of Science Express. Maybe you have heard it. In every year there is an Science Express which travel throughout India to reach, to showcase the scientific achievement in very easy, very simple exhibition. So when I was in BSc, this Science Express came to Lucknow, and I was the first. This was the first time when I saw such kind of exhibition, and it motivated me to do a lot more. So, and he was part of it, and he traveled throughout country to to inspire people. So that is the kind of experience he has with that. And later on, he worked as physical research laboratory in Anprobe Laboratory in Planetary Sciences Division. And later on, he went to University of Copenhagen, Denmark, at Center of Star and Planet Formation to do his PhD at in this PhD, he explored meteorite samples. Meteorites are the rocks from outer space. So he has a great experience in that field, and his passion for science outreach, science education is really inspiring for all of us. and he presented his research work at various national and international forums and actively participated for popularization of science. So his love for science, passion for education, and vision for research makes him the best person for interaction session like ours. So it is, I have been fortunate to spend some time with both of these experts at when I was at Physical Research Laboratory, and I'm really lucky to know them well, and they happily agreed to join us. So thank you so much, Manish, for being here and agreeing and being joined our interaction session. For from your busy schedule, you spare time for us. Thank you so much.
Thank you so much, Lalit. Hello, everyone. Thank you so much, Lalit, for giving such a nice introduction. And yes, I'm very pleased to be a part of this session, and I will try to contribute and motivate as much as I can to the young students. Thank you.
Yeah, welcome. Very for this interaction session, when we were planning at the planning part, so what we thought that we can give a talks or presentation kind of thing, but in general, what I thought that the people, most of the people who are the participants of this celebration, they are the young students of graduation, BTech, PhD. These people are there, so they are looking forward to make a career in science. So it will be. I'm sure that they may have a lot of questions about how they can do what is best for them. So the floor is open for questions. Anybody, any of you, if you have any question about from their field of expertise, like in astronomy, astrophysics, planetary sciences, data sciences, and science, what is the importance of science activities, how we can make career, how we can go abroad for degrees. So a lot of that things which you have in mind, you can ask your questions. It is in talk. The series will be in a kind of, this introduction session is in talk mode, very informal. Don't need to worry about things. Anything if you have in mind, you try to ask us, and they will try to answer you in that way. So anyone want to question? Any question about the field, anything? Ajay Srivastav, can you hear me?
Yes, sir.
Yes, you are quite active in class. See, these people are there. Anything you can ask from the field, and anything if you have in mind, you ask. You used to ask a lot of questions, so that is why we didn't put a presentation thing.
Okay, sir. Sir, I will ask in some minutes, sir.
Okay.
Okay,
So,
sir.
Okay.
I think students are a bit shy.
So, being shy. So yeah.
Something interesting about my research. So in the meantime, they will get warm up with their questions.
Sure.
So basically, I work in extragalactic astronomy. So it's beyond the galaxy. So I look for the galaxies which host the black holes. And I started my research at Physical Research Laboratory, where Dr. Manish is the doctoral fellow. And I have used the optical telescope, which is hosted by Physical Research Laboratory and Government of India. So it's situated at Mount Abu. So I usually make regular trips to take the observations of those galaxies, like for 4 years. And I have worked on that optical data. And I have also used the space satellite data in gamma rays, X-rays, and IR and UV. So when I came to PRL, which is Physical Research Laboratory Ahmedabad, so Lalit, um, he was already there. He's a nice colleague, and we had several interaction sessions regarding science and the research careers initially. And I know Manish, he worked as a project student, right? So we are meeting like after long years, like we've been seeing after long year. And I'm
Yes,
also,
that's true.
yeah, and I'm
Yes.
also working as a in science outreach activities. So this platform is a very good initiative for young minds to have good questions about science and how to pursue their careers, or whatever you have in your mind, you can just talk to us casually. Like we are like you, it's just we have a bit of experience in the expertise. So we also started where you are right now. So it would be nice if you have good questions. No question is silly. So you ask questions whatever you have about your career or education or anything related to your career paths. So we are open to discuss.
Yeah, thank you. Thank you.
Yes, so I will add a little bit to that. So thank you, Navpreet, for such a nice start. So young people who are joining today, they can ask any question. So like as Navpreet shared, we are just like us, but yeah, we have a bit of experience of working in labs or writing papers, research papers, or communicating science. So yeah, you can ask any question related to the experiments, or if you want to know about how to make a career in science, or why should we do a career in science, or whatever, or science education. So yeah, this platform is like, it's not like a formal session. It's a very informal session, and you can ask anything you want related to studies, related to education, science outreach. If you want to know more about how you can communicate whatever you have learned in your studies or anything. So yeah, I know Lalit and Navpreet both, and we have spent a lot of time together in lab, me and Lalit. So we were working together at PRL, where I started my research career, and then I moved to Copenhagen, Denmark, where I have studied the meteorites, the rock from outer space, to learn more about how our solar system was formed, what were the conditions at the initial stages of our starting of our solar system, and what these rocks, ये जो meteorites हैं, जिन्हें हम उल्का बोलते हैं, तो ये हमें क्या बताते हैं, ये जो पत्थर है, जो they are coming from outer space, so what do they tell us about our solar system and our universe, and yeah, many things. So you can ask many questions, as we said. Thank you.
Okay, so apart from this introduction and direct questions, there is one other option is there. People can write their question in chat so that we can look at the question and take the question for discussion also. So we could have talked a lot of things, a lot of work, but we decided to keep it formal so that we can take queries from students. So there is one question from Ajay Srivastav. He says that I want to build my career in astrophysics, but I opted BSc honors mathematics. Then how I can build my career in astrophysics? Which institutes are best for in this field? So Navpreet, can you guide this? He's an undergraduate student. He is doing BSc honors in mathematics. So what he can do later on and to build a career in astrophysics? So kind of like how we got into it. So you can share your story and talk about a little bit about that.
Yeah, thank you, Lalit. It's a very good question by Ajay Srivastav. And I think since he has opted BSc Mathematics honors and to work in astronomy, astrophysics field, so we need a curiosity to get into that field. So if you have a mathematics as a tool, it's a great start. And you can look for the institutes within India. Maybe IIT could be a good option where you can go and interact with the faculties to have a project there. And later on, you can pursue masters with PhD. Or you can look for the universities where you can have the master's degree in astronomy and astrophysics, which is rare in India. But you have to figure out what universities offer those MSc in astronomy or astrophysics. My personal opinion is to reach out to the faculties or researchers in reputed research institutes like IIA or TIFR in Mumbai, and do a collaborative projects, short-term projects, and then get into the master's degree as well as continue with your research programs. If we are looking outside India, so it's a lot easier to get into the astronomy course. Like they offer a lot of master's degree program in astronomy or astrophysics, no matter what your background is in during bachelor's, then you can continue further in that research area. Since I was personally, I was from physics honors background, it was a lot easier for me to target the universities and get into the astronomy, astrophysics. Most of the Indian universities they require masters in physics, if I'm not wrong. You can correct me, Manish and Lalit.
Yeah, you explained it well. If there are two ways we look forward you have to decide that whether you want to do it in India or you want to go abroad. So there are some systems, there are some exams. So you go for it. You have to target where you want to go, and then you qualify the basic exams. And basically, what Navpreet told, that you have to interact with the people who are working in the field, like researchers, young researchers from India also. You will get people who are working abroad. They are from India, so it is easy to approach to them. Even in abroad, if you write to any faculty, any researcher, mostly they respond very well. In India, maybe it is it may be a bit difficult, but getting abroad is not that challenging. It opens a lot of options, but depending upon your situation, you can opt for different options. Thank you, Navpreet, for answering this. Now there is another question from Prayoroshi Misra. Prayoroshi Misra, he's asking, good afternoon. He says good afternoon. Good afternoon, Prayoroshi. What basically is science outreach? I have heard it before, but I don't have a proper idea what exactly it is. Please elaborate. So he's asking science outreach hota kya hai? So since Navpreet, you are active in science outreach, both of you are active in this field. So I would like to have your thoughts about how to say that somebody who doesn't know what is science outreach. क्या साइंस आउटरीच में कुछ कैरियर भी हो सकता है, या साइंस आउटरीच का क्या मतलब है, क्यों करते हैं, थोड़ा सा इस पे हम लोग बात करें. So I think that will answer this question.
So I will start first.
Yeah, you tell about what is science outreach. Then I will take comment from Manish also.
Sure. Basically, when we say we are engaged in science outreach programs, it basically means that we are making a normal public understand about what science is. So since it's to reach out to the people who do not have expertise knowledge in science field, but still we could communicate what we do in labs or behind the scenes to the normal public, which has a lot of applications which they use in a daily life. So science outreach is to uh, it's basically an exploration program, you can say, for the young minds to also have the careers, what careers they can opt in science, and to have them in confidence that what they can pursue if they opt science as their career options. So what we do is we arrange the events at different places, targeting where there is a lack of information or knowledge. So currently, we are doing is to populate the knowledge of students, teachers in the rural areas of India. So basically, we are translating what we do to the normal public who do not understand what science is and how to go about it. So it's just a way to express the knowledge or spread the knowledge and awareness about science.
Yeah, basically, you see there is a lot of people who are working in science, and there are a lot of achievements, but it doesn't go to public. So there should be some kind of a channel, some kind of mechanism who
Yeah.
take that knowledge to common people, so that people can understand the capacity and its effects on society. So basically, the people who are active in science outreach, they create channels to take that knowledge to common peoples, and society with scientific temper, the scientific understanding has a very great direction to move forward. And we see that a lot of things around us are developed in some phase. That science is, it is not that development in science technology is affecting us, but many times it happens that people don't know about it. So the people who are active in science outreach, they do it. And basically, if you see the people who work in a science outreach field, they are doing science also, but they take some time for that, and they take to reach to the people. They participate in the event like ours to take that. So Manish is also, he has done a lot of work as a science educator and science outreach activities. I would like to hear his point of view also, so that that very good question from a student, that what is the science outreach and why we do it. So maybe he can get an idea about.
Sure. So yeah, thanks Navpreet and Lalit for the nice overview of the science outreach. So like they said, is it's basically science outreach means whatever is known in science that is communicated to the people, to the rural areas, and to the less unknown or less explored areas of our country, or in any country. So for example, science, I mean, I think the science outreach can be done in two ways. You may have heard, आप लोगों ने सुना होगा, there are some institutes called community science centers. So community science centers, what they can do, what they do, they hire people who are working in science, or who have studied like science, like masters in physics or chemistry or biology, or even PhD. So they hire them, and they do different programs, for example, in different schools. So they go, and they go to different schools, and they explain the basics of science through the interaction, through the activities, and through the small experiments and all. So this way, and the other way, like for example, the researchers in our research institutes like PRL, or ISRO, or Vikram Sarabhai Space Centers, or any other research institutes within India or abroad. So they are actually doing science research. They, if they are going to somewhere, to some workshop, or to the community, and they talk about their research, it is also a part of science outreach. So this can be done in both the ways. The another project, as Lalit said, it is a major project of the Department of Science and Technology, DST, by the Government of India. That there is a Science Express. It is a train which is about 12. There are 12 compartments, 12 or 13 compartments, and there are several science exhibits and posters and many things. And the train runs across the country and then stays at each platform for about 2 or 3 days or 3-4 days. So it runs the project runs for about 6 to 7 months, and it runs across the country, and it stays, for example, it stays at Lucknow for let's say for 4 days, and the people can come and visit the train. So they enter the train, and the whole train is full of exhibits, and in each of the compartment there are two science communicators, which is hired by the government, and they are salaried person, of course, but they know what are these experiments or what are these posters about, so they interact with the school children and local people and other community people. So yeah, so the people can come and visit the train and have a knowledge about many things about science. So this is also a part of science outreach.
Yeah, thank you, Manish and Navpreet, for your comments, and I hope he got an idea about what science outreach is. And actually, I would like to say that all the people who are studying science, they have a kind of responsibility to tell what science is and how it is powerful. Like in our society, you see there are many time people have superstitions. They don't have an clear critical thinking about when you think when you make decision by your scientific thinking, then life becomes quite easier. Like life science can affect various aspects of life and our way when we make decisions in our life. So the scientific thinking will really help us to make life easier. Like science invention make life easier. Similarly, like science thinking makes life easier. So when you think scientifically, and everybody, all of us, who are a part of it, they can be in science outreach activist. Science, you can wherever you are living, you can talk to people. You can take young students. We can like we are talking. You can talk about it. You can tell that how like you see. India is doing Mars mission, Moon mission. So you see this in news, but many times, if you look at the news, the people who are telling the news, they many times they don't know much about science. But the people, when we are part of it, we know things in better way, so we can communicate with people. And those people who are following this science superstitions, बहुत सारे ऐसे superstition हम लोग की society में लोग follow करते हैं. They are not scientific. So since we know, we can tell to them, we can talk to them, and in our family, in our friend circle, anywhere we can talk about science. We can tell the people. So all of us can be part of this movement, and as a whole, when society starts thinking scientifically, life becomes easier, life becomes better. So since both of our experts are very active, they are contributing in their busy schedule. There are a lot of research activities, a lot of things they are doing for in their work, but still they find out time for such activity like ours. Like we are having an interaction. So this is the way we reach to we take science to everyone. Now there is another question from Harshit Dwivedi. Harshit Dwivedi, he's asking question about solar system. Manish, I think you can take it for the comment first. Why haven't Jupiter onwards planet condensed to have a solid terrain? मतलब जो दो तरह के हम लोग देखते हैं सोलर सिस्टम में. तो ये बोले कि why Jupiter onwards planets, gaseous planets, why they don't have solid terrain, why are still gaseous, why they are gaseous and have higher gravity compared to terrestrial planets like Mars and Earth. So since their gravity is higher, but still they are gaseous. Why it is so? You please take this question and tell about the solar system.
Um, yeah. So the other question that I'll take first, why they have higher gravity as compared to the terrestrial planets like Mars and Earth. So as compared to the terrestrial planets like Mars and Earth, Jupiter is a very giant planet. The gases that it contains, the mass of these gases. So of course, like terrestrial planets, the gases also have mass, as you all know, and the gases that it contains, the amount of those gases are very, very high as compared to the terrestrial planets. And the terrestrial planets doesn't have atmosphere, as you all know, or a very thin atmosphere. And so why does it has a higher gravity? We don't know actually, because in the center of Jupiter also, people have theories, and people are still working on it. Actually, the planetary scientists are still working on it. And the Jupiter also it says that the hydrogen which is there in the core of the Jupiter, it is a kind of a different form of hydrogen, which is called metallic hydrogen. And the gravitational force of the core is such a high that it has contained a lot of gases when our solar system formed. So it's basically why it has a higher gravity, because of the higher mass. That's what we understand from the standard solar system models, or the solar system evolution. And planets condensed to have solid terrain. I think when the planets were formed, so all the so I guess there was nothing left except the gases when the Jupiter was formed, and so that's why it has only gases. Because when the terrestrial planets formed, the material that was there, they had all these material, and there was only the gases were left. So, and the Jupiter, after the accretion and pebble accretion and many more stuff, so it has accreted a lot more amount of gases from the surrounding, and that's why it has only the gases.
Okay, thank you,
But
thank
it's
you,
still,
Manish.
yeah.
I think it answered the question. First of all, that the planets which are closer to sun, I think they are high temperature. So because of that, there's this atmosphere has to face a different kind of thing. And the planets which are gaseous planets they are far from sun, and they have an heavy mass, so they create nearby things. Whatever are there close to it, a lot of gases or whatever it comes close to Jupiter and that planet. That is why these are gaseous planets, and basically it major role is played by what is its distance from sun. That is why its terrain, maybe we say this terrain is gaseous, but for other planets, so rocky planets, they have solid. But as you told that even for Jupiter, Saturn, when we really don't know clearly if its core is gaseous, as we say, like metallic hydrogen. It can say, you can say just gases, but is it is heavy metals? Heavy materials is in the rocky planets are made up heavy elements, and the lighter gases are contributing in the formation of gases planets. Okay, so thank you for this explanation. I hope he understands. There is one question by Akhil Mishra. He's a BTech computer science student, and it's a very good question. He is asking, can one star turn into planet? I think Navpreet, you can take this question. He's asking क्या कोई star planet बन सकता है? It's a very good question.
Yes, it's a very good question. Yes, a star can turn into a planet, which is a pseudo reality, because it only applies for specific stars like brown dwarf. So, जो brown dwarf होता है, that's an end stage of a star. So some scientists believe that okay, so it can turn into a planet because of its low reservoir, because जो hydrogen होता है, like it's a end stage of the star, it's a death stage of the star, all the hydrogen is consumed. So that's why it can turn into a planet, but in the initial stages of its death, so it still glows up because उसके पास अभी भी हाइड्रोजन का अमाउंट है which makes it glow. उसमें से लाइट आता है in form of magenta color or reddish color. So and after that, when all the hydrogen is consumed, so it turns into a dark death star stage, which you can call it as a planet, which is like it's a there are two school of thoughts. There are scientists who believe that it could be a planet. Some scientists do not believe that it could be a planet. So the answer is yes, star can turn into a planet, but only in special case of brown dwarf. So जो brown dwarf होता है, so it could be present in our galaxy in a Milky Way. So it is not rare to detect, but it is hard to find because it do not emit any light. So if we are not seeing any light, we cannot detect it. So I hope I answered this question.
Yeah, Navpreet, thank you. Basically, as you see that star, हम लोग किसको star कहते हैं? Star is like which emit light or like a source of energy, a fusion. Hydrogen is burning into helium in our sun, so that is a star. And in higher stages, star is born and then it evolves and then it dies. So after the sun-like star, what it happens when all hydrogen is burned up, so it turns into a dead star. So then it is like a planet. Planet किसको हम कहते हैं? जैसे हमारा एक सोलर सिस्टम है, सोलर सिस्टम के आसपास एक set of planets बन गया. So there is a definition of planet, like you say in our solar system, Pluto is sometimes considered as a planet, sometimes it says it's not a planet. So there is a definition. So if you go according to that definition, as Navpreet says, that there are two school of thought. So in that way, you say this is not a planet. But if you say planet is like a dead star, it is something which is like it is not fusion reaction is not going on, then you can say it is a planet. But so you can say it planet or not. You say it is not a planet, but star is something where this fusion reaction is going on. So there is a critical mass. How stars are formed. So there is in cloud, interstellar cloud, the material get condensed, then it achieves a critical mass so that there's a hydrogen burning star. So if hydrogen burning star, then it is a star. And if there is no burning and all fuel is gone up, then you can say it is likely it is a planet. But I hope you understand what we mean by saying it, because like in school we say this definitions, but if you go really in science, if you probe deeper, then you find a lot of things, things which is not that clear. Their definition is for us to understand. When you probe in reality, the definitions start breaking up. So that is why this planet and star thing, it's very clear, but still, if you take that question, so you can get sometime yes, sometime no, but I hope you understand the concept. So thank you, Navpreet, for answering this. Now there is one question from a student, Prithvi Avasthi. I think he's doing graduation in chemistry and want to make a career in cosmochemistry, but haven't got any focused idea how to make my path in that field. So I think we have an best person to answer this question. He's doing career in chemistry, graduation in chemistry. How he can do make career in cosmochemistry? So he knows what is cosmochemistry and how to make it. So Manish, please take this question and
Yes.
make it. Thank you.
Yes, sure. So yes, Parthivi Avasti. Okay. So yeah, so cosmochemistry. In cosmochemistry, there is a lot of chemistry, of course. So yeah, so you are doing your graduation in chemistry. So in cosmochemistry, what we do is we normally take a piece of rock, a piece of meteorite, and we so either we do a lot of chemistry and so we dissolve it using different acids and stuff, and then to basically understand about to basically study the isotopic composition of those rocks. It is basically a core of cosmochemistry. In cosmochemistry, you do a lot of isotopic study of the rocks of the meteorites. And of course there is in the experiments a lot of chemistry is involved. So when you are doing when you complete your graduation in chemistry, the best thing is doing a masters, your masters in chemistry. uh, and then there is a you can make a career in cosmochemistry by going into the PhD or the PhD program or the research field. But there are very few options in India who are doing which institutes who are doing cosmochemistry. So like for example, PRL is one of the institutes where you can start your career. You can also do a project during your masters, I guess, or even after your BSc.
In
So you
graduation
can have
also, there
a
is a summer internship program. So
yes,
look forward
yes,
at physical research laboratory. Summer internship
yes,
programs are there, so you can apply there. And
yes,
we are here to support you to give recommendation for this. So if you are interested, you
yes,
can go to PRL and means you first identify institutes in India, because as Manish said, there are not many options in India. That is why you are not getting an idea about it. But
yes,
since you are interested, so we are there to guide you, to support you. So yes, Manish, please
yes.
continue.
And there, yeah, and there are many more options in outside India, like in abroad. So if you so after finishing your masters in chemistry, you can start approaching to different institutes who have programs in which have programs in cosmochemistry, and write to the faculties that you are particularly interested in this particular field. And yeah, so it can be done in that way.
Yeah.
So
So
by approaching
basically, in
different faculty
cosmochemistry, there
members
is
and
a
yeah,
lot of things. So either you, like Mani said, what he is doing, he takes samples, extraterrestrial samples, like some sample from asteroids, some meteorite samples. There are some very specialized mission conducted by different agencies like Japanese agency, NASA. So then an asteroid, they go on asteroid and take sample back. And after the sample comes back, there is a lot of information about that. So we have to do a lot of chemistry. Like I can tell you one example. When I was at PRL, what we do in meteorites, we do a lot of chemistry. We try to find out we try to separate different minerals, like silicon carbide, for an example, is a very early forming mineral. Like when a lot of material eject from a star, it gets condensed in outer space, then minerals start forming. So silicon carbide was formed, so it condensed at very high temperature. So when we get meteorite, it has some minerals, some grains of that particular mineral. So for that total rock, we want to separate that mineral without harming it. So we develop a very specialized method to remove other. First we remove silicon, then we remove alumina and other, and then we reach to it. So the people who are working in chemistry, their expertise in chemistry is very much needed. And nowadays, if you look research, then research is a multidisciplinary thing. So it is not an like if, it is not that if you are in chemistry, then also you can switch into different things. And in India also, it is being realized. New education policy, if you look at its agenda, so it is diluting that concrete boundaries. The real boundaries doesn't exist. The people who are working in classroom chemistry, they might come from different background. Like we both come from physics background, but we used to do a lot of chemistry in lab, so clean chemistry lab, and we have to do this. So the people who are good at chemistry, they are needed there. So sometimes our channels are like that, that the people don't know the way, and at the end we need people from the field. So such kind of interaction will make a way for that. Like you are interested in classroom chemistry, and there is set of people who need people who are interested in classroom chemistry, and they work in lab. So it's really great. It is like one of objective of our interaction is being fulfilled, that you are interested and you are meeting the right person. You can you can write to even Manish, the email ID. I will share it later on. You can take his email ID from me, and then you may go there for a summer internship program, a 2-month summer program at PRL, and they offer a lot of things. So you can get a real experience how we do classroom chemistry at this. So that is good. Thank you, Prithvi, for asking this question, and I hope you got this. So after that, there is not a question in chat. So if anyone wants to ask, okay, I don't think he's wanting to ask anything. His mouth mic is muted. This one. Anyone want to ask anything? Otherwise, what we will do, we can, in a continuation, we can talk about, like, Navpreet. She has, tell me some your experience about this science Mela. What kind of questions and what kind of experience it was in 2019 when this United Science Forum organized in Science Mela. So probably the people who are joining us, they can get an idea. Like, because these kind of events is very rare in this part, at least. Like Manish tell, the Community Science Center. It is in Ahmedabad, but I think in this side, in northern part of India, it's not much of work that kind. So please share some of your experience about that Science Mela and how it was.
Yes, sure, Lalit. Actually, the idea, it was originated on a very short notice. So we are a group of researchers who are working abroad and within India, who have planned to have some organization which can contribute to the science education for the rural areas, where there is impossible for the unprivileged students to reach out to have the science education or the knowledge about how they can pursue their careers in science. So it was on a very short notice, like a month ago. So we had this idea together, and we made it possible to have a Science Mela at Azmalpur in 2019. So it was a wonderful experience, having a short notice and organizing so many things, going physically. I couldn't go there because I was
it was
so I was virtually participating in the Science Mela. So the people who were physically present at Azmalpur, so we took took help from all the local authorities. We took the permission, and we could organize somehow that festival, which was a big success. And I was responsible for forming the science quiz questions for all the students starting from class 1 to class 10th. So we made a subgroups for the science quiz questions for class 1 to 3, 4 to 6, and the 7th, 8th, and the 9th to 12th. So in that way, we had the subsets of science quiz questions, and it was quite a lively and very, it was a good event when the science quiz event had happened, because all those questions were very, you can say, naive, or people knew that, but they don't know how they could think about that answer. So they have heard about it, but they do not have the answer for that. So few have them, few had them, and few didn't. So we had several activities, including science quiz. We had arranged the projects, which were mechanical projects, where the students from different schools, they participated, they displayed their science projects in science field in different subfields like physics, chemistry, environmental sciences. So it covers all the broad areas of science. It's not only physics. And we have several competitions, essay writing, uh, uh, and essay writing and other research topic discussions amongst the students, including the teachers from all the schools from the unprivileged areas. And apart from that, we have the local public who was more enthusiastic about this event, because it might be it's the first time it's happening in that.
Yeah, that is the thing, that it is quite rare such kind of events in this part of
Exactly.
India.
And our number was like more than 2,000, like it was more than 2,000 people, they appeared on that day, and we could.
It looks, it feels very nice when you get young people and they are curious. They want to know way out. They are interested, but many times this lack of information, the lack of guidance, that is one thing that it needs very. Means we have good institutions, we are doing research, but also we need to take it to common people. And when there are, like you see, I remember once in PRL when there was a solar eclipse. So there was a program where you saw what it is, how this is happening. But in general common public, there are a lot of things, a lot of superstitions are there. So when you reach to people, then they know what it is, how it is. We can show it. So science is not something like hidden. It is clear. We can discuss it. So it is really nice. I'm sure that you enjoyed it. Although you couldn't come. I was also invited there, but I couldn't go because of some schedule. But nowadays, because of this, probably because of this pandemic, a lot of exposure to this information and communication way have been changed drastically, and this data and availability of data and internet facilities, the things are really making really helpful. Like we are meeting here, otherwise this kind of meeting, to arrange this kind of meeting, we need a lot of preparations, and here we can meet and talk. So this is really nice. Thank you for sharing your experience. And now we have some more question. Ajay Srivast is asking. Prithvi Avasi, I will share the email of Manish, Dr. Manish Sanghani with you, so you can write. If you are a student of PRL, student of SRMU, then you can write to me anytime. Otherwise, you are a part of this WhatsApp group, so you can message me and I will share his contact detail. You can write Manish, and then you can go further. So Ajay is asking, what is mean by stellar and planetary formation? So Manish, can you answer what is this? You have been looking this kind of question. So what is, he's asking what do you mean by stellar and planetary formation? Basically, you can take this story kind of thing, how this formation.
Yeah. So what does it mean by stellar formation? So stellar formation is the term which is used for explaining the formation of stellar means is the star. So when the star forms, so Lalit has briefly explained how the star forms. So there is a cloud of the huge cloud of gas and dust, and it is gravitationally collapsed. So it is collapsed under its own gravity and forms a sun or a proto sun in the center, and then later on, after a few million years, there is a evolution of the planets around the sun, and the mass of more than 99% of the mass is the solar mass. And then there are planets and the rings and the moons around the planets, and other things are formed gradually when there are different processes which are going on. Uh, uh, so yeah, so it is basically the stellar formation means it's formation of the star, and then the planetary formation means there are different planets which are forming around the central star, the proto star.
Yeah, Manish. Yeah, thank you. So basically, Ajay, he said thanks. So he got what he wanted to know. This is stellar and planetary formation. Is how this the process how star forms,
Yeah,
and
it's
this
the
is
name
a
of the
cycle.
process.
Like if you see in around us also there are cycle. Like a star forms, then the star evolves, and the star dies, and then when a star dies, it explodes a lot of material in the space, and then this material, that is the kind of material where again this material comes in another form, and then new stars are formed. So interstellar clouds, the big clouds, the stars, death of a star, formation of a star, this goes on like in our solar system form. So you see, when after Big Bang, the first set of stars formed, then they died, then other stars. So this is generation of stars. Like when our sun is formed, this is called third generation of a star. So in the formation, there were heavy materials, because in initially there was only hydrogen, helium, and some lithium, beryllium, boron, very small amount there. But in this star formation, it's the heavy materials. All heavy materials are formed in stars. Like in our body, we see calcium and all the kind of material. This all formed in stars. So that is why we say we are form of star dust. So this is interesting to know that we are also the material of that part. But the good thing is that we are like I'm not exactly remembering what Feynman says. Sometimes there was a statement by Feynman when he said we are exploring ourselves. Matlab, can you say, Manish, do you remember that statement when Feynman
I,
somebody?
I guess the quote is something like when we are looking at the universe, or when we are looking at the atoms, so it's something like the atoms are discovering, or atoms are doing research about the atoms, something like that.
Yeah. Matlab, like we are universe,
So, yeah.
part of universe, and exploring it. So we are like exploring ourselves in that way. So all the body, in our body we have all heavy materials. It is made of calcium, iron, and all. This all material is formed in stars in heavy temperatures when this nuclear fusion reaction occurs. So this is
Even the carbon
interesting
and
that
nitrogen and other stuff.
we
Yeah.
look forward that. Yes. Okay, so there are some more things. Prithvi Avasi asking, atom is 99.99% empty space. Is the space inside the atom is same as outer space fabric? So, Navpreet, can you say बेसिकली जैसे हम लोग कई बार स्पेस का बात कर रहे हैं, तो मे बी थिंकिंग दैट स्पेस 99% atom is empty space. So inside the atom there's empty space, outside the space. How means maybe it's like can we see that what is that going on inside? Like when we go in school, we learn that there is a nucleus and electrons are revolving around it. When we look at solar system, then we say there is sun and planets are revolving around it. So is there some model which goes on throughout the universe, or something you'd like to talk about that? Something?
Yeah, it's a very good question actually. So I think so what we see inside an atom is what we see in the space. So space is, if we say, it's empty, it's completely empty. And so the objects we see, they make up like 4% of the matter which we see visually. So there is a 95% to 95 to 96% is dark matter, so which we cannot detect. So the outer space is made up of 4%, which is nothing, we can say. So
Yeah. You see, means like you see, that says 99% of atom is space is empty. Similarly, when you say go in like we can't say that on a similar footing, like in school, how we see atom and solar system, and we try to see some correlation, but the physics. That is the thing. That is the questions are fundamental question. They remains as it is. When we go at higher, we see that still we want to answer that. We are looking for its explanation.
exactly, when we talk about atoms, so we are talking at a miniature level. So when we talk about the space, so when we talk about the heavenly bodies, celestial bodies like planets, stars, and galaxies, like a big group of stars and gas called galaxies. So then it's just an extrapolation of the miniature to the extreme environments, but the the basic physics and the physical phenomena remains the same. So the workings of physics remains the same if we talk about the atoms and we take it to the outer space, because all the matter is made up of atoms there as well. But it's just that it's many folds larger than what we see in like at a
Yeah,
miniature level.
means like you say, this is there is an it looks like there is some symmetry inherent in nature, but if you explore that symmetry, you find there are imperfections that is like in difference. They look things in different way. So that is the beauty of science. And this question comes in means you're curious about it, and the people who are asking such questions, they go deeper. They
It's a very
probe.
interesting question. Like I wanted
Yeah,
to
yeah.
add one more point here, is that since we study heavenly bodies like stars, black holes in outer space, so the conditions there are extreme, and the size of those objects are extreme, which we cannot built on Earth to study their physical phenomena. So that's why we have the liberty to study them in space. We go to space and use the telescopes to study them, to understand the physical processes involved, all the energetics, so all the extreme like I don't want to get into the technical terms, but it's the extreme environment. Like we talk about the emissions, like non-thermal, thermal emissions, or non-thermal emissions. So it's still a question in our research field how it works. So yeah.
So yes. So that is like, and we initially we were thinking
Over
that not many questions are there, but people are asking questions. They're getting these questions are. It is interesting
So
to
yes,
take questions.
I,
So Manish,
I
there
will
is
add a
one
little
question.
bit to that. Sorry.
Yeah.
Sorry,
Okay.
Lalit. Yeah.
Sure.
No, just I wanted to add a little bit of that, so that since the scales, the atomic scale and the larger scales like galaxies and cluster of galaxies, the fundamental forces that work, they are also different. Like in the atomic scales, there is a strong force, and in the larger scales, the gravitational forces are stronger than any other force.
Yeah, that's true.
And the phenomena that we understand or that we study, they are also different.
Yes. But what I was thinking in the terms of physical processes where we could not test those physical phenomena in the lab. So we cannot
Yes.
generate those environments, like we cannot generate extreme temperatures. Like we have the IPR, like Plasma Research Center in
Yes.
Ahmedabad, where we could
The
not
fusion. Yes.
reach up to the temperature of the core of the, like even the surface of the star. So
Yeah.
in, yeah,
Yes.
yeah.
Yeah, it happens. Like there is a great experiment is going on fusion, but it is not easy to design such an experiment. Such extreme conditions, it is very challenging. So
Yeah.
we have an opportunity to study that conditions by using our telescopes or sending satellites on. Basically, for Navpreet, can you answer one thing very simply? Like sometimes we do observe at Earth, and sometimes we send satellite to observe. So what is the missing? Why we can't do it at Earth? Why we have to send the satellite to observe? Is there some? Uh, can
It's
you
a
tell
very good,
that?
a very nice, curious question. Like,
Yeah.
why we have the space satellites to observe the, outer space? So it's because of the atmosphere layer we have. So, so we have an Earth and we have a thick atmospheric layer, so which only allows a window from IR to. So there is a small radio window. So there is IR and optical window. Only IR and optical can pass through the atmosphere. So all the X-rays and gamma rays have been like absorbed by the atmosphere. So through which they undergo the cascade process. So which we term it as a scintillation, atmospheric scintillation. Basically, we have a electromagnetic spectra from radio to gamma rays. So only optical and IR part can reach to the Earth. So the light in optical and IR can reach to the Earth. And to study the stars and galaxies in X-rays and gamma rays is not possible from Earth. Like we cannot observe them through ground-based telescopes. So for that, we need something which is beyond the outer space. So we have to send the satellites around the Earth to monitor those objects in X-rays, gamma rays, or high energy.
Yeah. Thank you. So basically, you have worked on an optical telescope at Mount Abu, and also you have worked and analyzed data from AstroSat. So since you have been part of these both kind of experiments, so I thought the students who was interested in the field, they get in basics why we need to do that. So basically, there are some high in some energy band, some which we can't do it on Earth. So that is why we send a space satellite to observe that. Thank you so much. And Manish, can you tell me a little bit about from where we get these asteroids, these meteorite samples in lab? So from where they come and what kind of information they can provide as a foreign young person perspective who is not much aware about it.
Okay. Again, very good and curious question. So people are always curious about the rocks and other stuff like, oh, really, this rock is coming from outer space? Oh, I want to touch it. So it is always like that. So these rocks, you can find it anywhere on Earth, because so you might have heard about this meteor shower. So there is always rocks are always entering on Earth, but many rocks which are entering on Earth. So they have there is a there is a layer of atmosphere. So when it enters, so it will get a friction, and some part of, or the outer part of that rock, so or the bigger rock will break apart, and it will turn into the small rocks, and then it comes to earth. But it's not very easy to get them anywhere on earth. So sometimes, so there are now many satellites. There are missions that are continuously monitoring the rocks which are coming near to earth, and which rock is, or which or asteroid is colliding on earth. And then it will, like, how big it is. And there is a network of satellites. I guess in Australia somewhere there is a network of satellites and telescope which are continuously monitoring. So yeah, but you can easily get it where there is a very less population, or very low human activities, such as the parts on earth, such as the poles, like North Pole and South Pole, as well as the desert areas like Sahara Desert. So it is very easy to. So there is a lot of ice spreaded on the surface. So in the white background, you can easily detect the rock, the piece of rocks. So there are several missions. So people are getting trained to go there on the polar sites, and then they collect the meteorites. There is a mission that I know is called ENSMET, Antarctic. I forgot the name, but it is a Antarctic. That there is a mission that that train the people, around 30 people. They go to Antarctica, and then they stay there for like 30 minutes. Sorry, 30 days, and then collect the samples. So yeah, and then there are samples, and then people also so like in nowadays, people go to moon, and people also go to Mars and asteroids, and collect the samples. We do not have sample yet from Mars, but we do have samples from asteroids, and we do also have the samples from interplanetary dust. There is something called interplanetary dust particles, which are also very useful. So we have those samples on earth, on different universities and institutes and museums. And then other I mean, the institute one institute can get the samples from other institutes as well, if they want to study different kind of rocks. Like in PRL, we have meteorite rocks from, also from moon. We have rocks from moon. We have something called a very
Martian
pristine
meteorites,
meteorites,
yeah.
which is called carbonaceous chondrites, like Murchison and Murray. And it is also interesting to know that whenever they are finding the rock from a particular place, the rock is given that name. For example, Murchison, it is a place on earth where this rock was found. I have studied two different kind of meteorites called Ishievo, which is a Russian meteorite. So it was fall on the place which is called Ishievo. And similarly, Northwest Africa. So there is a desert area called Northwest Africa, where people go and get these kind of rocks. And these rocks provide very different, very interesting knowledge about formation and formation of our solar system, how our solar, what were the conditions at the time of the formation of different planets. And they also have these tiny particles, which is called the presolar grains, which were formed, like Lalit said, which were formed in stars beyond the before the formation of our solar system. So before the formation of our sun, there were these minerals were formed in other stars, and then they incorporated in the molecular cloud, and then later in our solar system, which is a part of and then later in meteorite, which is a part of our solar system. So they give us the information of the journey of from where the grains were formed from stars to our solar system, and how they were altered in interstellar space, and many different stories. So it gives us a full story of of the and also the elements. So how these elements were continuously evolved, which is called the galactic chemical evolution. Like Lalit said, the elements are formed in within the stars. Like hydrogen is converted into helium, and helium into carbon, and other like magnesium and aluminium and stuff. So these elements are also like continuously evolved. The composition of the galaxy is continuously evolving in terms of the chemistry. So they can also provide the information in this way.
Yeah. Thank you, Manish, for explaining a lot of things. How these asteroids, these meteorites comes in, and what we can know about that. And there is one question is it possible to find some new kind of molecules from asteroids? So
Yes.
I think it is possible,
Yes.
and
Yes. Definitely. Yes.
yeah, and
Yeah. So
many times what we do in
people are
our labs,
finding. Yeah.
sometimes we look for an isotopic composition. Normal, the silicon carbide is there in we can make it in lab also, but the silicon carbide what we get from meteorite, its isotopic composition is different. Like carbon has three isotopes, silicon has different isotopes. From different isotopes are formed from because of different nuclear reaction. From that nuclear reaction, you get an idea about what was happening in that star when this grain was formed. So, from the basic scientific things, you get to know about greater detail of that star, which is not there now, but which contributed in formation of our solar system. So that kind of things are there. Still, there are a lot of questions are coming in, and we have like I'm taking one question from Akhand. He's asking, being in astrofield, what do you think of higher dimension? Can something like multi-universe or brand could physically exist? Navpreet do you like to take this question? He's asking, do you think higher dimensions uh, and multi-universe kind of thing, do these things exist? What do you think about it?
Yeah, it's a very, again, a very good question because it's highly debatable. So, so basically, the multi-universe concept, it has come from, it's a hypothetical group of parallel universes. Like if we talk in terms of quantum phenomena, so we do talk about the, so there, if we do talk about the parallel universe concept, that so the multi-universe could comprise of where it is entirely different space, time, and energy, and it could coexist. So we do not have any evidence about it, but we do have a hypothetical or theoretical predictions about the multi-universe. So since I am not very sure about how to go about it because I haven't really worked in that area.
Yeah. It
But
is not an area, but means this is, as you
also,
told, it is a theoretical concept predictions, and at this stage, what we know, we can say that it doesn't exist or it exists, but we are looking forward for it. No, is it?
it's basically a quantum realities. Like if we are talking about talking at a quantum level, so thinking in terms of quantum physics, so multi-universe could exist, but yeah, it's just a theoretical concept.
Okay, so yeah, we have been interacting for more than 1.5 hours. This was planned. We were thinking to have an interaction for 1 hour, 1.5 hour already we have done, and still there are questions, but we will limit now. So it is really wonderful to have both of you. We have interacted for a long time. By this means, it is like we could talk for. Like we used to talk, we used to sit there, and there are a lot of scientific communication, scientific discussions were there when you were there. And now these young students who are part of it, and initially they were shy about questions, and now we see there are a lot of questions, there are a lot of curiosity. So it fulfills the objective of this session, and I hope these young people who are with us, who are listening to our discussion, they will explore the unknown territory of science, and they will enrich the understanding of word about the questions. The questions are fundamental. The questions they are asking, they are still, the questions are very important, and these questions will lead to the new inventions, new discoveries. So,
Exactly, Lalit. There is a one very good question by a student about gravitation waves. So if you don't mind,
okay,
can I have?
maybe I missed it. So yeah, you can answer it.
Okay, so this question is again by Ajay Srivastava. So he asks, so what are gravitation waves and what is what is mean of ripples in space-time curve? How can we detect it? So basically, what are gravitation waves? So it's a very it's basically was a hypothetical, like a theoretical idea by Einstein about the gravitation waves back in 1930s, which did not have any experimental evidence. So in 2015, so a team of research scientists, though they have proved that the Einstein theory was correct because they have detected the gravitation waves. So what gravitation waves are? It's basically a ripples uh, in space-time fabric. So we have a space and time. So it's a hypothetical space-time fabric. So we have a mass. So we have a heavier object, and the space-time fabric is stretched. So when we have any activity, so any intense activity, so it will emit the waves in the form of gravity waves. So these gravitational waves, they are originating from three possible means: by supernova, if in outer space there is a supernova event happening, or there is a collisions of two black holes or neutron stars. So the discovery happened in 2015 by LIGO researchers. So LIGO is a observatory, one in like in US. So this discovery has proved the Einstein theory correct with the experimental evidence, and they won the Nobel Prize for this a year later. So so we can detect them, of course. So we have a very sensitive instruments. So it's called the interferometry technique we have used. We have more than 4 kilometers, two arms suspended perpendicularly across the two cities. And uh, we detect the waves, like we detect the signals from the outer space. And if there is any shift, any delay or shift in the length of the arms, so we can say that, okay, so there is something we are detecting from outer space. So that is a signal for the gravitational waves. So all the arrangement is done with like mirrors, lasers. So it's very highly sensitive instrument called LIGO.
Yeah. Thank you so much for explaining it well. I missed that question. So gravitational waves and how it was detected, and what was the technique for that, and they got Nobel Prize recently. So it was in news at that time. That a lot of people were talking about gravitational waves. So this student, he's quite curious about things, and he's more into this. So I'm sure that he will be exploring further and doing good in his career. So that is very good, and I really like Manish is there, but I don't know. He can you hear me, Manish? Probably some network issue at his end. So it's already more than 1.5 hours.
Thank you for giving me a time to explain that part.
And that's very good. We answered almost everything. And initially, I was thinking that I don't know if student will be asking questions or not, but a lot of very good questions came in, and we had a very good discussion over it. So this is really nice. And now, Manish, I can't hear him, and probably he's having some network issue at his place. So we will be winding up now, and looking forward to meet you sometime again.
Sure.
Okay, thank you, Navpreet. Thank you so much for taking time from your schedule and being with us and answering all the queries and patiently listening to everyone. I hope our students have really enjoyed it. And
Thank you
so,
for having me here. It was a great interaction session with the student. Yeah, of course.
yeah, Manish is back. So, Manish, can you hear me now? You are, please unmute yourself.
My internet connection
Yeah.
was unstable.
Wow,
Sorry.
wow.
Yeah.
Okay, that's fine. So now we had a very good session, and we talked about a lot of things. I'm really thrilled. We like virtually meeting after a long time. So
Yes.
hopefully we will meet sometime again in such kind of
Yes, definitely.
initiatives. And
Yes.
so thank you so much from on behalf of my institute and university, who is hosting this event on this occasion. I could get you, and you take time from your schedule and interacted with us for more than 1.5 hours. David. So thank you so much. Thanks a lot.
Thank you very much, Lalit, for inviting us, and it was a very nice session. And I hope young people could and students could learn what they wanted to learn. Thank you very much.
Yeah, and I will those students who are interested to know more about cosmochemistry or astronomy, astrophysics,
Yes.
and if they want to write you, I will share your email
Yes.
with the students.
Yes.
So
Sure. Yeah.
that is good.
And good luck to all the students who are joining today for their studies and their higher education.
Okay. Thank you, Navpreet. Thank you, Manish. I'm happy to meet you again.
Thanks, sir.
Thank you, Ajay. Thank you, everyone, all the participants and the students
Thank you,
who were
everyone.
with us. Thank you so much. So we are closing the session. We'll meet in next session. Thank you. Bye bye. Have a nice
Bye-bye.
day.
Bye.
Bye.